Let's do a couple of examples of the Hofmann elimination. We're going to start really simple, and then we're going to work our way up to some tricky examples, tricky problems on sapling. So a lot of times when this reaction is written, it's written all together as a two-step reaction, starting with excess methyl iodide, and then followed up with the silver oxide, Ag2O, water, and heat. And when we have a really simple symmetrical alkene or amine, then we know we're doing a straightforward elimination reaction. We know that we are eliminating the NH2 group. We know that we're going to be forming a carbon-carbon double bond. And like I said, because this is very symmetrical, this is the only possible product that could be made. So this is a very simple example. Here's one that is slightly trickier, but still not that tricky. We have excess methyl iodide followed by silver oxide, Ag2O, water, and heat. And again, we're going to be eliminating the amine group, and we're going to be forming a carbon-carbon double bond, which could be here, or it could be here, or it could be here. We've got a couple different places where this one could go. So there's one possible product right there. And this looks like it's going to be our major product for sure, because the major product is our least substituted product. And then here is another product, which would be minor. And as I'm looking at these, I'm looking for the potential for cis and trans isomers, but there aren't any. So now I'm going to move on to a couple problems on sapling that you have. So this is in your chapter 23, part 2 homework. And the first thing that we're going to look at is problem 5. This one is amazing because it requires you to remember Newman projections. And what a great time to review the Newman projection. So this problem is a little bit different because it is starting you after the step 1 addition of the methyl iodide. And so we're starting with our alkylated amine ready to go, and it's telling you that the reaction makes 2 products, which they're calling A and B. And so the first thing that it wants you to do is predict which one is the major product, which is easy because it's just the most substituted product. And then it wants you to fill in Newman projection for the perspective, the confirmation that would give you product A, and also the same thing, fill in the Newman projection for the confirmation that would give you alkene B. And it's starting you with the nitrogen with the methyl groups down at the bottom. So this is what they're giving you to go off of. Like that, and it wants you to fill in the rest of the sites on the Newman projection. So this is kind of tricky. So when we're looking at the formation of A, based on the location of the double bond, in the formation of A, we're dealing with this carbon, which I am going to make red, and then we're also dealing with this carbon right here, which I'm going to make green. So that's the location of the double bond. So looking at the Newman projection A, the carbon that has the nitrogen on it, which is our back carbon here, that's the green carbon, the green dot. And then our front carbon, I'm going to circle red. So there I've just tried to kind of translate from one representation to the other. And so now we're pretty ready to fill in our Newman projection. What's on the red carbon? The red carbon just has 3 hydrogens on it. That's very straightforward. And then what about what's on the green carbon? The green carbon has a hydrogen. It also has the nitrogen, which we already have built in for us. See, what have I done with my Newman projection? Hold on. Got crazy with my hydrogens there. So the green carbon has the hydrogen on it, it has the nitrogen group on it, and then it has this isopropyl group in the back. And we just have to pay attention to the position, the relative position of these three substituents, and make sure that we put them in the right place on this Newman projection. This would be a good time to dust off your model kits. You can build your model kit right now and take a look at where those substituents sit. Or maybe at this point you've just done enough stereochemistry that you can kind of visualize the position of those alkyl groups. So now we're going to move on to B. When we move on to carbon B, I'm going to erase my dots here because we're going to have to make some new dots. So when we're moving on to B, and we're forming a carbon-carbon double bond now between two different carbon atoms in the molecule. So one of those carbon atoms is going to be the red carbon, and the other carbon atom, I'm going to hopefully get this correct. I'm going to call this guy the red carbon. And then I am going to make this one the green carbon. The nitrogen is on the red carbon. So now the nitrogen in our Newman projection is on the red carbon, and this guy is our green carbon. So we're sighting from a different angle this time when we're looking at our molecule. Green carbon is now in the front, and this green carbon is achiral. It has two methyl groups on it, so there really isn't any wrong way that we can stick the methyl groups on this Newman projection because it's achiral. For the red carbon, we have the amine group, we have a hydrogen, and we have another methyl. And again, we've got to be careful that we're putting them in the right position on this. So again, break out your models, or just kind of twist your head around so you see this from the right angle. And that's a pretty tricky problem. Question number 6 is also an amazing problem. So one of the things that you may have been wondering, all the examples that you've seen so far, our amines initially have been primary amines, and that's just been a coincidence. This reaction is not restricted to primary amines. Here we're going to do it on a tertiary amine. So the wording on this problem is that we have excess methyl iodide, we have silver oxide, Ag2O, and then we have heat. And it wants you just to draw, just draw the structures of the products of this reaction. And it says products, plural, so it wants more than one. It doesn't say major or minor, it just says products. And it says organic products, so it's not looking for us to, let me scroll up here. It's not looking for us to draw the byproducts. The early problems on sapling, I think questions 1 through 4, are expecting you to show the byproducts of the reaction. This time, no byproducts, it just wants the organic products. So that means that we want to be drawing major and minor products both. I find it really helpful with some of the trickier Hofmann elimination problems to go ahead and draw the alkylated nitrogen. And this time, because our nitrogen already has 3, the original nitrogen already has 3 alkyl groups on it, we can only fit 1 methyl onto that nitrogen, so I'm only showing 1. And now we are ready to do an elimination reaction. And for this molecule, we've got a few options of where to eliminate. So one possibility would be for us to put a double bond between these 2 carbons and break this particular bond. That would be one option. And what would that look like? What would that give us? So one of the things that's going to be really interesting about this particular reaction is that we are not going to end up with the nitrogen gone. We're just breaking a ring. So there's one possible product, and that looks like a good product because that's a mono-substituted alkene. So that's a pretty it's going to be a pretty favorable product. But that's not it. Now don't think we're not going over here to this side of the ring, because putting a double bond in that position and breaking that carbon nitrogen bond is just going to give us the same thing that we've already drawn. So another option that we have is to put the double bond up here, like that, and break this bond, that particular carbon-nitrogen bond. So let's see what that product looks like. This is going to end up being like an expanded ring, which you can draw like that, kind of funny looking. Sapling is happy with that. And if we tried to go onto the other side of the ring, we would end up with the exact same molecule, just kind of flipped like a pancake. So our third option here would be to break or to form the double bond between these two carbons. So that this carbon's getting picked on twice, and to break this carbon-nitrogen bond. And let's see what that would look like. This looks like I'm drawing a superhero logo. So there's that molecule right there. So these are three possible products that we could get from this reaction. And this one looks like it's definitely going to be the major product. And this one, which is the most substituted, looks like it's probably going to be the minor product. Although this one might have some really weird bond angles at this carbon right here. So it might end up being less favorable than the other one. However, this particular problem is not asking us to rank major and minor, so we don't even need to worry about that.